Hi everyone, and apologies for the slight delay there, just some technical issues. So welcome back. Welcome to week 4 of the exam countdown for Leaving Cert Higher Level. So for our full members, you will be familiar with our week 4 countdown material from the website, and you have a checklist there of what should be covered by the end of the week. If you're not one of our full members, don't worry. I will be giving you some links to some free material in the chat as we go through. Okay, so we'll jump straight in, and we're this week going to start looking at some cubic equations. Okay, so just to start off, to remind ourselves, what is a cubic equation first of all? So we look at the 3 types of equations that we're familiar with from our study of maths over the past couple of years. So our linear equations, those are the equations of degree 1. So those are the ones that the highest power of x is just an x to the power of 1. For example, you might have something like this: 3x plus 4 equal to 7. Okay, and we know that if we were to graph that function, it would just be a straight line, positive slope or negative slope. Okay, and we also know that to solve that equation, we would be trying to get the x on its own. Okay, a quadratic equation was the second equation that we come across in our study of maths. So a quadratic equation is one of degree 2. So it might look something like this, for example: x squared plus 4x minus 5 equals 0. Okay, again, we're familiar with from a couple of weeks ago, our quadratic equations take the form of a u shape if it's a positive x squared, or an n shape if it's a negative x squared, n for negative. Okay, we also know how to solve those quadratic equations. We normally solve them either using guide number or minus b if required. So today we're going to have a look at cubic equations. So you guessed it, a cubic equation is one where the highest power of x is an x cubed. So it's an equation of degree 3. For example, it's an x cubed plus 5x squared minus 4x plus 3 equals 0. So that's just one example of a cubic equation. Again, it's called a cubic because it has the highest power of x as a 3. Okay, so what we're going to look at today is, first of all, what cubic equations look like if we were to graph them, what they would look like, and secondly, how we would solve them. So we're already able to do it for linear equations. We're already able to do it for quadratic equations, and hopefully by the end of today, this lesson, we will be able to do it for cubic equations. So to start with, what does a cubic equation look like if we were to graph it on graph paper? So I'm just going to draw a rough sketch here. First of all, one cubic equation might look something like that. So it's basically just like an S on its side. And another cubic equation, different type of cubic equation, might look like that. So again, it's an S on its side, but it's kind of inverted as well. You will notice from what I've just drawn that the cubic equation in both cases, they both cross the x-axis 3 times. So those places where the cubic equation crosses the x-axis, those are just called what we call the roots of the cubic equation. Just like we have roots of a quadratic, where the quadratic crosses the x-axis, the roots of a cubic are where the cubic equation or the cubic function will cross the x-axis. And our roots are basically just a fancy name for our solutions. So if we were to solve a cubic equation, our solutions would be the x values of where the cubic crosses the x-axis. Okay, so similarly over here, we have 1, 2, 3 points where the cubic crosses the x-axis. Those are our solutions, or our roots of the cubic equation. Okay, now that they're not the only 2 types of cubic equations or cubic functions that we can graph. We could also come across cases where if we have our x-axis and our y-axis, where the cubic actually just crosses the x-axis at 1 point. So it only crosses the x-axis at 1 point here. It's still a cubic, so it's still an S on its side, but which means it should have 3 solutions because the highest power of x is a 3. But this is its only real solution. So that's its only real root, which means the other 2, if they're not real, they must be 2 complex roots. Okay, so we dealt with complex numbers the 2 weeks previous to midterm. So this particular type of cubic equation has 1 real root. In other words, it crosses the x-axis once, and it has 2 complex roots. So it still has 3 roots, but only 1 real. And another type that we might come across Again, it's going to be an S on its side, something like this, but this time it crosses the x-axis clearly here, but it kind of just skims the x-axis or sits on the x-axis right here, okay? So what we have is we have one root here, and what happens here is we have a repeated root, okay? So the root repeats itself twice. For example, this might be, that might be maybe x equals 5, and this point here, again, I'm just pulling these numbers from the top of my head, but that might be x equals 3. So your three roots would be x equals -5, x equals 3, and x equals 3. So remember that if it sits on the x-axis or skims the x-axis, you're going to end up with this, what we call a repeated root. So it repeats itself. Okay, so just to go back here very quickly, something I forgot to mention, we have two different types of cubic equations here. So the general shape is different. One of them starts off as an N shape. So you can see here, if we read from left to right, this one starts off as an N shape and turns into a U, whereas this one over here starts off as a U shape and turns into an N shape. The one on the left, when it starts as an N shape, that's when the coefficient of the x cubed is positive. And this one here, when it starts as a U shape, is when the coefficient, so that's the number in front of the x cubed, is a negative. So slightly kind of the opposite to the quadratics. If it starts as an N shape and turns into a U shape, it's going to have a positive coefficient, a positive number in front of the x cubed. And if it starts as a U shape and turns into an N shape, its coefficient of x cubed will be negative. Okay? So we have looked at what a cubic equation looks like, or what a cubic function looks like. Now we're going to look at how we solve them. So as I mentioned up here, we can already draw linear, we can already solve linear equations. We can already draw quadratic and solve them, and we've looked at what cubics look like, but now we're going to talk about how we solve them. And something that's very, very important for solving cubic equations is this huge big idea called the factor theorem. So I'm not going to go into the factor theorem in too much detail here. I'm just going to barely skim over it and use it for the questions. But there is a link to the video on the factor theorem from our website in the chat. Okay, so any of you maybe afterwards, after the half an hour, if you want more detail on the factor theorem, if you want to go into more detail, there's a video there in it. So this is the factor theorem, and I've tried to simplify it as much as I can for you. There's obviously a lot more of a mathematical way of going about it, but I just tried to simplify it as much as possible for you. So the factor theorem tells us that if f of k is equal to 0, so we're assuming k is just a real number. So if f of k is equal to 0, that just means that if we sub k in to our function f of x, so we sub k in and we get 0. Well, what that means is that k is then a root, and remember we said earlier that a root just means it's a solution. It's a root of the equation, and therefore if k is a root, then x minus k is a factor. Okay, so we'll notice from here, x equals k is a root, that's my root, and that means that x minus k is my factor. So we're going to use those in an exam question in a second, so that's important to understand that. How did I get from the root to the factor? Well, I've just moved the k back to the left-hand side to be with the x, okay? So that's why it became an x minus k is my factor. So like I said, there's a video in the chat, and any of you that are not full members and want to have a little bit more of an in-depth look at the factor theorem, you're going to find that in the chat, okay? So let's get straight into it, and we're going to have a look at hopefully 2, maybe 3 exam questions. We'll see how we're doing for time. Our classes today are 30 minutes, okay? So 30 minutes. We will be finishing up about 7:15. Okay, so first question that we're going to have a look at is from 2017 exam paper, and it's paper 1, and it is question 5. So let's have a look at the main things from the question first of all. It's giving us the function f is such that, so there's our function f. Not a bad idea to maybe highlight it. You're going to use that in the question. It's a cubic function, and just to recap, it has a positive x cubed. So if I needed to remember, I know that it's going to be this shape if I was graphing it. Okay, it's a positive x cubed, so it starts as this N shape, and it turns in to a U shape. Okay, it's also telling us that x is a real number, so no complex numbers here. And in part A, it asked us to show that x equals minus 3 is a root of the function. And then once we've done that, we're going to find the other two roots. Because remember, it's a cubic. The highest power of x is a 3. So that tells us there should be 3 roots. They're telling us, hopefully, x equals minus 3 is one of them. And there should be another 2 roots as well. Okay, so how are we going to start by showing x equals minus 3 is a root? We're going to remind ourselves of what the factor theorem said. And the factor theorem can be applied in converse as well. Okay, so it works both ways. In other words, if I was to read it backwards, the factor theorem would tell me that if x minus k is a factor, then that means that k is a root. And if k is a root, that means that when I sub it in, I should get 0. Okay, so to show that x equals minus 3 is a root, I'm going to sub minus 3 into my function. In other words, I'm going to take f of minus 3. So I'm replacing my x. Everywhere I see an x, I'm going to replace it with a minus 3. So it becomes 2 bracket minus 3. We're always putting it in. We're always subbing in using brackets. Plus 5 times minus 3 squared minus 4 times minus 3 minus 3. So all I've done is I've replaced in this function, I've replaced every x with a minus 3. And when I do that, I can either put the whole thing into the calculator or work out each part separately. This is going to give me minus 54. This is going to give me plus 45. That's going to give me plus 12. And we've got minus 3 at the end. And all of those cancel each other out. Okay, so when we put that into our calculator, we end up getting equals to 0. So what we've just found is that f of minus 3 is equal to 0. And what the factor theorem tells us, that if it's equal to 0, so remind ourselves of what we said up here, then minus 3 is a root. So let's just make a note of that. Therefore, x equals minus 3 is a root. And again, as the factor theorem tells us, if that's my root, then how do I get back to my factor? Well, I just move this over to be with the x. So therefore, x plus 3 is a factor. Okay, so that's all just from using my factor theorem. What is a factor? What does it mean for something to be a factor? Okay, let's think about it for a second. You've heard of the word factors since you were in probably 5th or 6th class. Okay, what is a factor? Well, if we take just 12, for example, the number 12, for example, and if we think of the factors of 12, okay, 1 by 12, but 1 and 12 are factors, 3 by 4, 2 by 6. Those are all of the factors of 12. What does it mean to be a factor of 12? Well, if I take, for example, if I take 4 and I divide it into 12, it will divide in with no remainder. So let's make a note of that for ourselves. A factor will divide in with no remainder. Okay, so because 4 is a factor of 12, when I divide 4 into 12, it divides in a whole number of times and it gives me no remainder. My remainder is 0. And when I divide 4 into 12, I end up getting the other factor, which is 3. Okay, so the other pair of factors for 12. 3 by 4 is a pair of factors for 12. Okay, so back to our question. That's just a little side note. We've just worked out that x plus 3 is a factor of my function from back up here. Okay, so what we're going to do, because it's a factor, we know that it should divide in with no remainder. Okay, hopefully that's okay on your screen. Apologies for that. Okay, so we're going to divide x plus 3 into our cubic equation. So reminder of our cubic equation, it was 2x cubed plus 5x squared. So 2x cubed plus 5x squared minus 4x minus 3. Okay, and we're dividing it in because we know it's definitely a factor. We've just worked that out using the factor theorem. Okay, remember how to long divide. So remember your long division. And I'm just going to write a little hint down the side of the page to remind us of our long division. We first divide, then we multiply, then we subtract, and then we drop down. So DMSD is just a little hint that I use to remind myself of how to do our long division. Okay, so we first divide, we multiply, we subtract and drop down, and we lead with this first term. So very quickly, I'm sure you're all excellent at long division already. We're going to divide x into 2x cubed, and that's going to go in 2x squared times. That's our division done. Okay, next we're going to multiply that 2x squared. So we're going to multiply our answer from here by the x and by the 3. So 2x squared by x is going to give you 2x cubed. 2x squared by 3 is going to give you 6x squared. We're going to subtract. So I'm just going to change the color of my pen so I know that it's a change I'm making to the question. That becomes a minus and that becomes a minus. And when we do that, these should always cancel each other out. Okay, plus 5x squared minus 6x squared. I hope you can still see my screen. Just a little bit of an issue with our update to Windows 11. Okay, I hope we should be back to normal. Yeah, looks good from my side, so just let me know. Hopefully you are all finding it okay. So to continue with my long division, brilliant. To continue with my long division, I had a plus 5x squared minus 6x squared. That's going to give me minus 1x squared. My next step was to drop down, so I'm dropping down my minus 4x, and I'm starting the whole process again. So I'm leading with my x term. X divides into minus 1x squared minus 1x times. Again, we're going to multiply. So this time we're multiplying this by my two terms here. That's going to be minus 1x by x is minus 1x squared. And minus 1x by 3 is minus 3x. Again, I'm going to subtract or change the signs. So that's going to become a plus and that's going to become a plus. Again, those should always cancel. And we're left with minus 4x plus 3x. So that's going to give me minus 1x. And we're dropping down our final term, which is minus 3. Okay. And last time to do it, again, we're leading with this term x here, and we're dividing x into minus 1x. It goes in minus 1 times, and multiply. Minus 1 by x is minus 1x, minus 1 by plus 3 is minus 3. Last time, we're going to subtract, so we're changing that to a plus and changing that to a plus. And what you notice, or what should happen if you've done your long division right, everything should cancel out, leaving us with a remainder of 0, which we expected because that's what a factor means. It means it will divide in with no remainder. Okay? But remember the question asked us to find the other two roots. Okay? So we're going to go back to our answer from the long division here, because remember that's going to be another factor. That's the other factor of my cubic. And it happens to be a quadratic. So 2x squared minus 1x minus 1. We're going to let that equation equal to 0. And we're going to solve that equation using either minus b formula or guide number. In this case, it doesn't really make a difference. It doesn't state anything in the question that allows us to think that it has to be minus b formula. So you can do it either way. Okay, so I'll leave that to yourselves to do. And your answers are x equals 1 and x equals minus a half. Okay, and remember our other root from the start was x equals minus 3. Okay, we expected 3 answers because it was a cubic equation. So the highest power of x was a 3, meaning your answers should be the same number, 3. Okay, so let's have a look at another question. This time it is just slightly different at the start. This is a question from the 2012 paper 1 exam paper, and it's question 2. So again, I'm just going to highlight any information that might be important to us from the question. We're asked to solve this equation. So again, it's a cubic equation. It has a positive x cubed. So just to remind myself, that's what it would look like if I needed to graph it. Okay. We are asked to solve the equation. So as opposed to being asked to factorize, where we would need to find the factors, we're asked to solve, which means we're looking for the roots or the solutions. Okay. So we're hoping at the end of the question that we get x equal to a number, or in this case 3 numbers because it's a cubic. This next part is important. Write any irrational solution. So an irrational number, remember, is one that cannot be written as a fraction. write any irrational solution in this form, where a, b, and c are integers. Okay, so they're positive or negative whole numbers. Okay, so that's a huge big hint. We can see a surd here. That's a huge big hint that when we get to it, we have to use the minus b formula. Okay, it's a surd, or if it's at a decimal, that's our hint to use the minus b formula. Okay, so huge big difference with this one compared to the last one we've done is this time they're not giving us a starting point. This time they're not telling us what the root is. So in this case, we need to find our first root by doing a little bit of trial and error. So we need to try a couple of roots, a couple of numbers, sub those in for x. So remember what the factor theorem told us. The factor theorem told us that if when we sub in the number, it gives us 0, then it's a root. Okay, so when we go back to this question down here, our job is to first find that first root by trial and error. Okay, so you could maybe start with subbing in 0, then go to 1 minus 1. A big hint is it will be a factor of that last number there. So whatever the factor or the root is, it's always going to be a number that divides into the constant in your cubic. So in this case, 11 is a prime number. The only two things that will divide into it are 1 and 11. So I'm going to go first of all to start with 1. So I'm going to find f of 1. Remember, this is our f of x, our function here. That means everywhere I see an x, I'm going to replace it with a 1. And I'm making sure that when I'm subbing in, I'm putting it into brackets as well. So that's going to give me 1. That's going to give me minus 3, minus 9, and plus 11. And there we go. That should give me 0. Now, like I said, maybe you tried 0 first. Maybe you went to 1 and minus 1. You might need to do a couple of tries before you get the answer. So again, therefore, since f of 1, so since when we subbed it in, we got 0, that means x equals 1 is our root. And remind ourselves, how do we get from our root to our factor? We just move over to be with the x. So therefore, factor theorem tells us again that if x equals 1 is a root, x minus 1 is going to be your factor. What does it mean to be a factor? Well, it means that when we divide it in, it will divide in with no remainder. So we're going to do our long division. We're dividing our x minus 1, and we're dividing it into our cubic. So that was x cubed minus 3x squared minus 9x plus 11. So remind ourselves again of our little hint for division. We divide, multiply, subtract, and drop down. And we keep doing that until all of the terms of the cubic are dropped down. So we're starting with our lead term. We always start with that first term, x in this case, and we're dividing into the first term of the cubic equation. So that's going to be x divides into x cubed, x squared times. Multiply. X squared by x gives me x cubed. X squared by minus 1 gives me minus 1x squared. Subtract, so that gives me a minus, that gives me a plus, and as we expect, they will always cancel. We've gotten a minus 3x squared plus a 1x squared. That gives me a minus 2x squared, and drop down our next term. So drop down our minus 9x. Divide again, so we're dividing our x into this term, minus 2x squared. That will give me minus 2x. Multiply, minus 2x by x is minus 2x squared. Minus 2x by minus 1, be careful with signs here, that's going to give you a plus 2x. So minus 2x, we have a minus here, and we have a minus here. That's going to give me a plus 2x. We're going to subtract, so we change the signs. That becomes a plus, that becomes a minus. These cancel as we expect, and we've got a minus 9x minus 2x, which gives us a minus 11x. Okay, last term to drop down is our plus 11. So we're going to drop that down and start all over again. X goes into minus 11x minus 11 times. Answer goes on top, and then we're going to multiply. We're multiplying our minus 11 by our lead term x here. That gives me minus 11x. Minus 11 by minus 1 is plus 11. Subtract, so change your signs. And as we expected, because we knew it was definitely a factor, we end up with 0. a remainder of 0, because it should divide in just like 4 divides into 12, because it's a factor, then this factor should divide into our cubic. So like we did the last time, we're going to go back up here. We're going to take our quadratic, so that's x squared minus 2x minus 11. We're going to create an equation from it, so we're going to equal it to 0. Why am I equaling it to 0? Well, that's what was in the question at the very start. So the cubic at the start was equal to 0, okay? And remind ourselves, this time we cannot use guide number. Why? Well, remind ourselves of the question. They told us that our answers will be irrational. In other words, they're going to be a third in this case, in the form a plus b root c. Don't let this language in the question put you off, okay? Basically, you see a third, there's your hint to use minus b formula. Okay, so back to the minus b formula. We're going to remind ourselves what a, what b, and what c are, and we're going to write out our minus b formula, okay, which can be found on the page 20 of your log tables, okay, all over to a. So what are our digits? Our coefficient of x squared is a, that's 1, there's an invisible 1 there. Coefficient of x, the number in front of the x, is minus 2, and coefficient of, or the constant at the end, minus 11 is our c. So subbing in, we're getting x is equal to minus 2 plus over minus the square root of minus 2, making sure that's in brackets, squared minus 4 times a times c, all over 2 times a, 2 times 1. Okay, and we are basically throwing that straight into our calculator to get our 2 answers. The first time with the plus here, the second time with the minus. So your 2 answers should work out to be x is equal to 1 plus 2 root 3, and x is equal to 1 minus 2 root 3. So very, very similar answers. Okay, and let's just remind ourselves, always go back and check that you've answered the question. Okay, so always go back and check that you've answered the question. So if I scroll back up here to the question, I hope you can see that okay. The question asked us to write our irrational solutions in that form, so that's fine. They're already in that form, 1 plus 2 root 3 and 1 minus 2 root 3. But the question asked us to solve the equation. Okay, so our solution should have 3 answers. Our first answer, remember, was x equals 1. That was the one we found by trial and error. The second one we've just found from the minus b formula, 1 plus 2 root 3. And the third one, 1 minus 2 root 3. Okay, and those are our solutions or our roots, and we know that that's where they cross the x-axis. Okay, hopefully you could see my screen for the last part. We are having a couple of teething issues with a Windows 11 update, and I apologize if my screen was kind of, or my writing on the screen was a little bit delayed, but hopefully it worked fine for most of you. Okay, and hopefully that was helpful. Like I said, those of you that are our full members, you will have full access to your revision exam 4-week countdown, as you do every single week, and that's linked in the chat. And don't worry if you're not a full member, I've also linked 2 videos in the chat. The first one, as I mentioned, was the factor theorem, so more information on the factor theorem. And the second one was working backwards, so from where you're given the roots and you're working backwards to your cubic function or your cubic equation. Okay, so hopefully that was of some help to you guys, and I look forward to chatting to you next week. Thank you.